Hello everyone, good evening. So in this lecture I am going to explain about the classification of semiconductor. Like semiconductor are two type: intrinsic semiconductor and extrinsic semiconductor. Again, extrinsic semiconductor are two type: P type and N type. We'll discuss in detail. So without wasting time, we'll start the session. My name is SRP. You are watching my beautiful channel Love You Science. So let's start. So semiconductor are two type. One is intrinsic semiconductor. Second is extrinsic semiconductor. We can classify semiconductor in two categories. One is intrinsic semiconductor, second is extrinsic semiconductor. Intrinsic semiconductor is pure semiconductor. Extrinsic semiconductor is impure semiconductor. Matlab some impurities is there. So let us talk about intrinsic semiconductor. Let us take the example of silicon crystal. So these are the covalent bond. As you know, even if at room temperature, electron hole pair generates in semiconductor. That means at room temperature the bond will gradually break and electron hole pair generate. Matlab first point, at room temperature already you have electron hole pair. Matlab that semiconductor generates electron hole pair at room temperature. Let us draw the block diagram. These are the holes. These are the holes and these are the electrons. If we give a potential difference, then the electron will be attracted towards the positive polarity of the power supply and hole will be attracted towards the negative supply of the negative terminal of the power supply. So that means the current which will flow through the semiconductor is the sum of hole current and electron current. Hole current and electron current. So now the second point, if I increase the temperature, if temperature increases, then the number of electron hole pairs will be more. The number of electron and hole pair will be more. Are you getting my point? If I increase the temperature, there will be more chances to generate more and more electron hole pair. So that means for the smooth conduction or to enhance the conductivity, we need to increase the temperature or we need to give some kind of thermal energy to the semiconductor. And vice versa also can possible. If we decrease the temperature, again it will come back to its original position. So that means the major factor for conduction is to generate more and more number of electron and hole pair, and that can be possible if I increase the temperature. If I increase the temperature beyond room temperature, or if I give some kind of thermal energy to the semiconductor. So that is the biggest drawbacks in intrinsic semiconductor. So to overcome this factor, we can have extrinsic semiconductor. That means same thing will be reflected here. Instead of increasing the temperature, simply we can add some kind of impurities to the intrinsic semiconductor. Matlab intrinsic semiconductor plus some impurities will be equal to extrinsic semiconductor. Clear? That means to form a extrinsic semiconductor, we need intrinsic semiconductor and some impurities. That impurities is called dopant. That impurities is called dopant, and this process is called doping. Doping is a process by which impurities is being doped with intrinsic semiconductor, and that doping ratio is in terms of ppm, parts per million, like 10 to the power 8 number of tetravalent atom plus 1 number of dopant or 1 impurities. 1 impurity and 10 to the power 8 number of primary atom or tetravalent atom. Here, so ये हो गया doping. Next is the based on doping we can classify extrinsic semiconductor in two categories. One is p-type semiconductor, second is n-type semiconductor. P-type semiconductor and n-type semiconductor. As you know, the primary atom of a semiconductor is tetravalent atom. Matlab, if trivalent atom is doped with tetravalent atom, that will form p-type of semiconductor. I can take one example, boron plus silicon. Here silicon is the major element, or it is a tetravalent atom, primary atom, and boron is the dopant or impurity. Similarly, when pentavalent atom is doped with tetravalent atom, if pentavalent atom is doped with tetravalent atom, that will form n type of semiconductor. So example is phosphorus plus silicon. Silicon is the primary atom, phosphorus is dopant or pentavalent atom. That means here boron is the impurities, silicon is the primary atom, phosphorus is the impurities, and silicon is the primary atom. So that is the basic comparison between P and N type of semiconductor. So we'll discuss in detail how it works. Okay. As we know, extrinsic semiconductor are two type, p-type and n-type. In case of p-type semiconductor, trivalent atom is doped with tetravalent atom. That will form p-type semiconductor. Example, you can take trivalent atom like gallium, tetravalent atom like germanium. Here dopant is gallium and its primary atom is germanium. Similarly, in case of n-type semiconductor, क्या होता है pentavalent atom is doped with tetravalent atom. So let us talk about p-type semiconductor. In case of p-type semiconductor, your primary atom is germanium, which is tetravalent atom, and your dopant is trivalent atom, that is gallium. मतलब trivalent atom is doped with tetravalent atom. Trivalent का example क्या है? You can take the gallium. Tetravalent का example क्या है? Germanium. So here germanium is the primary atom, gallium is the dopant or impurity. So let us draw the diagram. So here I have taken germanium, gallium, germanium, germanium, germanium. Okay. So these are germanium atom, primary atom, and this one is your gallium atom, which is impurity. You know, since gallium is trivalent atom, it has 3 valence electrons, and germanium has 4 valence electrons. Let me draw. As I have told, gallium is a trivalent atom and germanium is a tetravalent atom. The 3 electron of gallium atom will form covalent bond with germanium atom. So in the fourth covalent bond, gallium is not able to participate since it has 3 electrons. Germanium has 4 electrons. It can give 1 electron to make the covalent bond, but gallium cannot able to give 1 electron for covalent bond. So that means one missing part is there. That missing electron is called hole. मतलब hole is a missing electron. Is it clear? So there are other covalent bonds. There are other covalent bonds. So here again I repeat, since gallium has 3 electrons, so 3 covalent bond will form in between gallium to 3 germanium atom. And 1 electron is missing to participate or to make the covalent bond. That empty space is called hole, or the missing electron is called hole. Matlab here 1 gallium atom will provide 1 hole. 1 gallium atom will provide 1 hole. The small amount of gallium will have million number of gallium atom, and that will provide million and million number of holes. Is it clear? So here the number of holes per unit volume will be more than number of electrons. Matlab number of holes is more than number of electrons. Actually, number of holes per unit volume is more than number of electrons. So we can say majority charge carrier is hole and minority charge carrier is electron. So in p-type semiconductor, again I repeat, number of hole will be more than number of electron, or hole density will be more than number of electron density. Number of holes per unit volume will be more than number of electrons per unit volume. So majority charge carrier is hole, minority charge carrier is electron. Let us draw the block diagram. So since majority charge carrier are holes, these are the holes, and minority are the electrons, these are the electrons. So if I apply potential difference, that electron will be attracted towards the positive terminal of the battery and hole will be attracted towards the negative terminal of the battery. So we'll be getting two current. One is hole current, second is electron current. Since majority charge carrier is hole, so electron current will be can be neglected. So that means the major factor for conduction of that type of semiconductor is hole. So now we'll discuss about N-type semiconductor. In N-type semiconductor, the pentavalent atom is doped with tetravalent atom. We can take the example as arsenic, tetravalent is germanium. Here arsenic is dopant or impurity, germanium is the primary atom. Let us draw the crystal lattice of that N-type semiconductor. This one is arsenic. As you know, arsenic has 5 number of electron in outermost orbit, and these are the germanium atom. Let me draw. So here the since arsenic has 5 number of electron in outermost orbit, the 4 valence electron of arsenic will make covalent bond with 4 germanium atom, and 1 electron is left. 1 electron is left and it is free. So that means one arsenic atom or one arsenic impurities will make 1 electron as free. So a sample of arsenic will have million number of arsenic atom. So matlab that will form million number of free electron. So matlab the number of electron per unit volume will be more than number of hole, or you can say electron density will be more than hole density. Most important point, number of electron will be more than number of hole per unit volume. Matlab here majority charge carrier is electron and minority charge carrier is hole. Majority charge carrier is electron and minority charge carrier is hole. Here, so if you draw the block diagram, since majority charge carrier are electron, these are the symbol of electron and these are the hole. Hole is the minority charge carrier. Number will be less. So if you give a potential difference, so here hole will be attracted, electron will be attracted towards the positive terminal and hole will be attracted towards the negative terminal. Since number of hole will be less as compared to number of electron, so we can say the current flows through that N-type semiconductor is due to only electron, or you can say majority charge carrier. So current due to minority charge carrier we may neglect. I think that is the basic comparison between p-type and n-type semiconductor. It's very simple. In case of p-type semiconductor, trivalent is doped with tetravalent. Example, gallium, germanium. In case of n-type semiconductor, pentavalent is doped with tetravalent. Example, arsenic, germanium. So here number of hole will be more than number of electron. Here number of electron will be more than number of hole. Majority charge carrier hole, minority charge carrier electron, majority charge carrier electron, minority charge carrier hole. I hope it is clear. So with this, I'm ending this lecture. Hope you guys understood what I've explained today. So thank you so much for watching my video. Thank you.